Okay, welcome to Defin episode 4. This is Vijay from Holland.
Hi, this is Ray from Belgium.
Hello Ray, how are you?
Pretty good. And enjoying the week's wonders of Brexit. But we're staying in Belgium, so I think it's going to be okay.
So we'll still continue doing Defin.
Yeah, we can do it anywhere. But
of course, we're online.
Yeah, we're definitely
it's been a pretty strange week for Britain. But anyway, let's get back to our non-political closure podcast. So this week we are going to talk about persistent collections. But before we get into the details, we'd like to do a quick follow-up. And first of all, we'd like to thank Mike Fikes, who joined us in the last episode to explain the REPLs of that he's building, Planck and Replete, etc. And we saw that Planck is trending again, and there has been a lot of activity, or at least interest in Planck on GitHub. And we'd like to certainly take the fame of advertising it.
Yeah, but it's... I mean, Mike was writing great code before and great code after, but obviously the podcast's what did it.
Yeah. And in case people didn't notice, then we just need to tell people that the Planck is now running on Linux as well, at least the beta of it, and also on Windows. So this is one of the questions that we asked Mike, and in a week actually, you see this happening.
Yeah, that was good.
Yeah. So people who are not on Mac, you can also get into Planck up and running pretty quickly, especially Linux as well. So news to rejoice. And continuing with the same theme, we'll have other guests in the future. So we are very excited to probably have some other interesting guests. We don't want to announce before we get a confirmation, but we want to have different people who are involved in the community and join us in the podcast and explain what they're working on, and that'll be a nice thing to do. And if you are one of them, we'd love to hear from you, and you can hit us on Slack or Twitter or all the regular channels of Clojure.
Yeah, I mean, we're awesome together, but a little bit better with other people as well. Yeah.
Exactly. And one thing that I'd like to point out is that we're already having almost an average of 1,000 listeners, or at least 1,000 plays on the SoundCloud. So it's pretty awesome. I think we're like the second biggest Clojure podcast these days.
Definitely the second biggest. Yeah.
Right after Cognicast. I haven't seen Cognicast numbers though.
Yeah, so, maybe it's the first. You never know. I don't know. Maybe they really compete with that those numbers? I don't know. I think okay. like you were saying before, though, it's just incredibly. It's actually a bit scary, just to be honest. It's certainly very humbling. Because I never thought that we'd get anywhere near that kind of number, especially on a regular basis. It's amazing. Okay, 3 years, not that many so far, I guess. So maybe it will all just tail off after the first 10. I don't know. But
we never know. But we can keep people with.
Let's stay positive.
Exactly.
Yeah.
But the nicest thing with having listeners is that they give us feedback, and we did get a couple of interesting feedbacks from the previous episode. One of it by Jason Gilman.
Yes.
So in the last episode we said that incorrectly that Atom's REPL is called Atom Inc. But he corrected us saying that it's called actually a proto-REPL. So the plugin that is used in Atom is essentially Atom Inc. and it's probably has a small role compared to the REPL. So sorry for that, but thank you, Jason, for listening to the podcast and pointing that out.
I'll take my 50 lashes, Jason. I'm very apologetic about that. Yeah, we can all sleep a bit better now, I think. And that's nailed that one. Yeah. We also, just by the way, there was not really follow-up as such, but there was a little discussion on the Twitters about whether Ramsey Nassar had done some work around the ClojureScript REPL. There was some guy asking about that because he'd heard on our podcast that Ramsey was doing some things via Mike. But Ramsey said, "Oh no, I just ported it to Node." So offhand. Yeah, I spent 5 minutes, just ported it over. But that's got a lot of portability, and obviously he's done great work there. So yeah,
it's really awesome to hear all this feedback, and I'm very happy that people are listening to it and telling us. And this is something, as I was pointing to you before the show, that we have 900 people, or at least I hope it's 900 people. It's not just one person listening to it 900 times. Telling,
they're really trolling us. That guy's really trolling us.
Exactly. But I love that, we're getting feedback from people, and this is basically, podcast is not only just telling people, but also learning experience for me, and I'm pretty sure it's the same for you as well, I think.
Absolutely. God damn it, yeah. I mean, we're like little babies in this pond,
Exactly.
We're getting our feet wet part-time. There are some people doing this full-time. Obviously, they've got core committers and everything, so we're very much... We're trying to educate, but also we definitely want to learn. I mean, there's no doubt about that. We're very open to feedback and very open to learning from the skilled people that are contributing a lot. And we definitely don't want to put ourselves up on a pedestal. That's for sure.
Exactly. But thanks a lot for your feedback, guys and girls. And we'd love to hear more. If you have anything interesting, or did you hear anything wrong or interesting, then if you... And we're also getting some positive feedback as well, and that gives us some energy to continue doing this one. But we want to move to the next section, or whatever we want to call.
We've got sections now, yeah.
Yay! So we are getting professional now. We'll get back to ad hoc pretty quickly, I think.
Yeah.
I heard that you were doing a presentation at in Belgium, right?
Well, actually, we're going to do a little a meetup this coming week in Brussels about live coding. So it's more of a kind of hack night. Hopefully, we're going to get people set up with. We've got a reasonable. It's a fairly small audience, but very very highly curated audience. Let's say who are going to come out on a Tuesday night in Brussels. And we're going to do a little bit of live coding, and actually we're going to do it with Boot and Hoplon, because we think that it's a bit underrepresented and it looks very interesting. I think it's going to be a fun evening, and it'll be very interesting to get a little bit of feedback from guys and girls, and we do actually get a mix of people. So. I tend to say guys, by the way, and I mean guys and girls.
Yeah.
I have to learn a bit because it's. I don't like folks for some reason.
Yeah, I think that's much better. That's
true. I'm not a fan of folks actually. Folk sounds like folk you, but I don't know. I don't know. We're living in a difficult world, but guys and girls and ladies and gentlemen and all people are welcome for sure. And so we're doing this thing on Tuesday.
Okay.
If
anybody's in...
Sorry, go on, Vijay.
Yeah, so a shout out to anybody who is in nearby Brussels. I think they should join and enjoy the company of Ray and other people who are making this awesome, I suppose. So...
You suppose?
Yeah. Supposedly, it's Belgium. If you have read Hitchhiker to the Galaxy, Hitchhiker Guides to the Galaxy, it's Belgium, man, Belgium.
That's awesome. Yeah, I think it's one of the reasons why Brexit is happening, because of Belgium. But I'll try and make it a bit less painful on Tuesday anyway. Okay,
I'm sure it's a pretty awesome place.
So one of the things in terms of like pain, I did want to have a little bit of a shout out about this disturbance in the force that happened a couple of weeks ago, where this Ashton Kermaling guy talked about various complaints and had a whole bunch of issues that he thought were beyond the pale, and it's a terrible situation. I don't know, what did you think about that whole thing, Vijay?
Yeah, I mean, I think people should express themselves. That's pretty fine.
Yeah,
but,
definitely.
I mean, obviously, we can't speak for the people without knowing them in person.
Yeah, definitely.
There might be a lot of frustrations behind the blog post. I mean, I appreciate the blog post, but I think the tone was a bit too harsh, I think. But in my opinion, I can say that for the both sides. When I say both sides, because he was complaining about the Clojure core committers not not responding to the tickets or something. I don't want to go into individual tickets or something, because Alex Miller did a great job of explaining the issues behind each of these item by item. He gave the response. So I think he did a pretty good job. But at the same time, from the side of Cognitect/Core, Clojure Core guys, it could have been a bit more diplomatic. It could have been more like a positive leadership sort of thing.
Yeah.
That's what my personal opinion is. I mean, again, I don't know Richiki in person. Obviously, everybody is doing everything, but especially when you're limited in communication on the internet, in Twitter or those things, then in my opinion, you should be more careful in terms of what you're going to say. So I was a bit surprised.
I think it's to be perfect. I think what happens is that people get frustrated, and they hear some of these negative comments come out, but I think honestly, as the community grows a little bit, you're going to get these odd people not the odd people. I mean, I think Ashton has got a voice in the community for sure, and he used it. He's entitled to do that, as you say. He's allowed to complain. People are allowed to complain. I think how we respond to that is important. And like you say, Alex did a great job of responding very patiently and very calmly. I wasn't very happy about the response of Rich and Stu about it, to be honest. I thought they could have done a more positive leadership role. But that's their choice, of course. But I thought it was a little bit snarky, which I don't think we need that. I understand that it's frustrating when people complain, and actually, one of the things that Alex said in his responses was that a lot of the things that are coming up through things like spec, etc., are actually helping to fix a lot of the concerns that Ashton raised. So I felt like it would have been a bit nicer just to have had a positive throw on that, and to say, hey, look, although you might think we're wasting our time here, there's a lot of good coming out of this stuff.
That's true, because the community is doing great things as well, because it's not just the Clojure Core. I mean, there are lots of libraries written by the community, coming from Ring and all the way to Planck, for example, all these things that we are using day in and day out. It's not just, I mean, of course, I didn't contribute a lot yet, but I can imagine we are standing on the shoulders of the giants, so everybody is doing their part. But I think you see this in every community. They go through this, there was an example like this: storming, norming, performing, in terms of the community probably. But everything. So every community will have their own left pad situation.
Oh Jesus! Yeah. No, but the funny thing about it was that I saw this thing from this Rob Pike. There was a similar kind of thing. This very recently, actually, even just a week or two ago, with Rob Pike saying, "Oh shit! All you people that don't know, I don't know, some floating point operations or something. If you don't know floating points or some other things, then you're not entitled to program anything." And it's oh my god, yeah. And apparently he then kind of recanted on this and said, "Oh well, it was negative, and what I really meant to say was, you can always learn more, and foundation stuff helps, and honestly, if you do the foundation stuff, it'll be better." But I think this is the sort of thing that we can learn from as a community. Basically, is we get frustrations. I understand that, but I think what would be nice would be to start looking at. I know Alex did something a while ago when he kind of joined Cognitect, because he's the kind of community outreach guy, basically, isn't he? And I think he's doing a great job in general. But they started to do this thing about, how one of the complaints, I think, or one of the issues is, how does Clojure work, and how does the community contribute? And there's some stuff around the documentation, but I checked it again, and it's a little bit untended. It's a little bit kind of, not very well. It's not part of this kind of refresh that Cognitect have had recently of their website. And they don't talk about it very much, and I don't know what you think. I think to make that a bit more transparent would be quite good.
Yeah, there has been a lot of discussion online about the way the project is run. I mean, I don't have any complaints about the way that it is run
No,
because
no.
I know the amount of effort needed by multiple people to keep a language and the core library up and running. Uh, but the thing that at least I have, I sympathize with the notion that we need to come to terms with how a project is run, because people say, hey, this is not real open source, this is real open source, or whatever. uh, it is Rich Hickey's project, and it is Cognitect's project, and makes sense. And we need to accept that it's not like a completely community driven sort of thing yet. Even in the community driven projects, I mean, you need a benevolent dictatorship. That's one of the things that I think is making Clojure great, because there is a lot of thought going into how to introduce new features or how to triage the things. But at the same time, it would be much more interesting if Clojure leadership or the core guys were much more transparent or explicit about these things.
Yeah.
So you were suggesting that there should be a nice talk about, or at least a talk at one of the conferences, right?
Well, that's the sort of thing that I think would be potentially very a good olive branch to the community to say, look, this is how things are organised. Maybe maybe do a bit more work on these kind of community-oriented things, and explain a bit about how it all works. Because you say it's like Rich Hickey's show, and he started it obviously, but there's more people involved now. There obviously Cognitect. There's a group of core developers there. There's a core team, has been for a long time. So it's definitely not just Rich's show. He's kind of like. He's the editor-in-chief, that's for sure. Things have to get past him, and it's great to have someone with his taste and his experience and all that kind of stuff being the editor-in-chief of the language. I think you need that, and you need a direction, and I'm all for that. And I think in the end, we can see that we've got a really great environment there. But I think we could just do with a little bit more explanation about transparency about that. And I think a conference talk from one of those guys would be really interested. And of course, we're going to the Euroclosure in October, and Cognitect are hosting it. So I think as a suggestion, a small suggestion. I think that would be my suggestion.
Yeah,
I hope I don't feel. If they don't do it, I don't. I'm not going to cry. Okay? I'm not going to write a blog post about it. But if they could do that, that would be really nice.
Yeah. I think it's like a community outreach, quote unquote community outreach talk or something. That'll be nice.
Yeah.
But anyway, I don't want to dwell too much on the news. Let's get to the meat of the show, or I don't know if it is called meat of the show. Probably.
I'm a vegetarian. I don't know about you, VJ. So.
Well, I'm a vegetarian.
Oh, it's a vegetarian show. This is why. So no meat on this show. Okay, this is a show without meat. Yeah.
Okay, so this is the best vegetarian Clojure podcast.
Yes.
Okay. Now we are the best in some category.
Yeah.
Okay,
excellent.
Let's get to the topic of the week, or the topic of the bi-weekly podcast. So we want to talk about immutable, persistent data structures. So first, let us see what kind of collections are available in Clojure, because one of the bread and butter, or the metaphorical bread and butter of all these functional programs, are basically lists. So, Lisp, list processing.
That's where we are.
Exactly. So obviously, when you're processing lists, there are two ways, or you can say actually three ways of storing the data, right? You have a data structure optimized for putting the data in front of the list. I'm still calling it a list, but and then you need another data structure where it is optimized for appending. So append optimized, and obviously you want a data structure where you want to be efficient when putting the data at the end and then taking the data from the front. So that's basically a queue. So you have three different ways of looking at the data structures that are list based. So obviously Clojure has list, and it has a vector. There are two important things, and I think list is fundamentally everybody who uses who read a bit of data structures knows what a linked list is. So every node has a link to the other node. So list is essentially a linked list. And then vector is a tree implementation, and then you have a way to basically vector. You can see it as a indexed indexed elements, so you have a really fast lookups and you can go to the item pretty quickly. So those are the kind of workhorses, so to speak, right?
Yeah, I think what I like about these kind of things is that when they were introduced, when Rich introduced all these, they kind of explained what the big O notation was around each of these things you were talking about. So they explained, if you want to access the nth record or append something to the end, these are the kind of performance characteristics you can get from that. And that was I don't know about you, but that was kind of the first time that I'd seen that in a language at a kind of I knew the big O notation before, obviously, but not obviously, but I knew the big O notation, but I didn't see it very very commonly on data structures. So I think that's one of the nice things about Clojure for me, actually, is that they're very open about that. They're very open about how the data structures are being designed, exactly to kind of to give people a lead on the kind of data structures they should be using and when they should be using them. And I think that's a really that's a great example, actually, to me of very simple but very powerful documentation.
Yeah, of course. I mean, because this is like a one-dimensional way of storing the data. Well, not one-dimensional, but essentially list is basically you have a bunch of things you want to store them, and you also need to store stuff that especially in Clojure you have maps and sets, and so a map is a map. It's pretty tricky to explain, right? Okay, you have a key and a value, so you want to have a associative data structure. That's what I was looking for.
Well, they call them dictionaries in other languages, don't they?
Yeah. I think in Python they're called dictionaries. I
think in Ruby as well.
Yeah, true. So it's basically an associative data structure. So you have a key and then you have a value. So you can have anything you want. Oh, that's another interesting thing in Clojure. If people who are used to the typing, then in a list you can store anything. I mean, it's not a list of ints, it's not a list of something. So it's basically heterogeneous. So all the data structures, Clojure being a dynamic language, in a vector you can store a string and a person record or anything you want. So,
that's actually quite one of the amazing things, actually, isn't it? That it's not like you have all these generic things, but you don't have to declare them as any's, or anything like that. You can just, if they are automatically, you can be homogeneous or heterogeneous as you see fit.
Yeah, exactly. And for the maps, it's the key can be any unique thing, obviously. And if you see the way all these things are backed by obviously Java interfaces. So if you want to build your own version of it, there are interfaces backed by all these data structures that we have. So and then there is set, which is basically a mathematical set. So all the unique elements will be saved. I mean, these things are pretty difficult to explain, right? I mean, how do you define a set is a collection of elements where everything is unique, right?
Yeah,
maybe that's it.
Yeah, I think so. I think, like you say, it's a mathematical set. I think that's people get that. I think
I'm pretty sure.
The main thing is that you can put the key in as many times as you want, or the key value pair, and if they match, then they will just get either dropped or they'll be put into the set. So that's really good. The other thing I find as well is that with keys and sets is that both the keys and the sets can be keywords. The keys and the values can be keywords, and that's also a bit it's a bit funky, isn't it? To have these. It's fine to have keywords as keys, but you can also have them as values as well. So that's kind of funky. I mean, I think the whole keyword concept is a bit lispy, isn't it? I don't see that in other languages.
Yeah, that's true. And also the nicest part in Clojure is that the maps are functions of their keys. So you can just use keys as a function. So that makes your code pretty clean, because you don't need to say get everywhere.
Yeah.
Get this key out. You can just say key and then the map, and then you get the value out. So that's nice touch, by the way, if you want to write clean code.
Yeah, that's a very good point, actually. Yes.
Yeah.
And of course the set things have all these relational operations as well. And they're they're deliberately outside of the core system, and that's one of his complaints actually from the earlier conversation. I don't want to get into the details of that, but but they're very definitely kind of outside of the core system. So I'm not sure.
But for the sets, I think from the implementation, not the sets, but the maps from the implementation point of view, they are I think they are extending the sets. So because map's property is that the combination of key value is unique, and a set is essentially the same, that every element is unique. So if you treat an element as a key value pair, so map is essentially a set. So I think in Clojure, map is I persistent map, I think, I for the interface, and then that extends the persistent set. So these things are, I think people can look it up easily and then they get it. But mathematically speaking, a map is nothing but, or not nothing but essentially feels and behaves like a set, because if you squint, then key and value to be single elements, then it's basically a set of key value pairs. But the interesting point in Clojure is that all of these data structures are there is an underlying structure called a sequence in Clojure, right?
Yeah.
So,
that's really a foundational thing, isn't it?
Yeah. So that gives you kind of you can get a sequence out of any of these data structures and then perform the operations that Lisp people are more familiar with. Basically first and the rest and next and cons and those kind of functions, you get them for any persistent collection. So that is one of the interesting features of Clojure, is that you have this sequence library that you can use, and you have the same functions working on any persistent collection that is implementing the seq interface, or not implementing but works with the similar structure. Then you can use first, next and cons and rest onto the same data structure. I think this is what you corrected me in one of those episodes when I said the 100 functions data structure thingy. Yeah,
you bring it up again.
Yeah, of course. Hey, I'm wrong, so I need to tell people I'm wrong. So
yeah, well, I don't mean to harsh on you.
It's like the internet thing, right? You just say quoted by Einstein. I don't know. Nobody knows.
That's true.
It becomes true.
But to your point though, I mean, this is one of the weaknesses of like earlier Lisps, wasn't it? Was that people tended to write kind of functions against their specific data structures, and one of the unifying things around Clojure was to have this common interface to all of the collections, so that you could do this kind of, again, if you code against sequences, and if you write your libraries to use sequences, then you get much more reuse of all of those functions, all of those common functions. So
you
it's
have a common baseline.
Yeah, so it's just one of these like design things, isn't it? It's good to be aware of. As soon as you put yourself into, well, I'm dealing with lists, or I'm dealing with vectors, then you're kind of boxing yourself in. So it's much better to have some kind of functions that will take a sequence and give back a sequence.
Yeah. And also all these functions, they're basically, if you put sequence in, you get sequence out. So it's you're working on a different abstraction. But there are some fun things people bump into, especially using all these functions, and expect different. They don't expect a different type, but that is one thing I think people need to be a bit more wary about, I think.
Yeah, because sometimes you find this, don't you, when you're doing the REPL, that you start to, I don't know, do some mapping function or something, and then you find that you get back a list where you really wanted a vector, so you've got to put a vec in, or you get back 3 lists and you really want to concatenate them, but you can't concatenate them in this particular instance. You've got to into them, or then you can concat them when you do some changes, and that's a bit annoying, actually, to be honest. But it's something you get used to, for sure. But you kind of you have to kind of. That's the nice thing about the REPL development, like we talked about last time, is that you can do all interactive stuff, see what the functions give you, see what this mapping function gives you back, adjust accordingly, and then you're off. But But actually, one of the things that we will talk about a little bit later is SPECTER, which looks at trying to unify this a little bit more. Do you want to just quickly talk about these other bigger functions as well, like zip and stuff like that? Because
so there is a closure zip, and then there is closure walk, and there is XML. All these data structures. Well, all these libraries, they can use the same interface to implement similar behavior. So you can have the first, rest, next, and all these functions. So the idea behind is that you have same lesser number of data structures, and then you have multiple functions operating on it. And then once you have a baseline, then you can implement your own persistent collections on top of other things as well.
Yes.
So that is an interesting concept in Clojure, though. So these are essentially the workhorses of Clojure, right? I mean, because Clojure is so data centric, you have individual atoms. Well, I don't want to call it atoms, but atom is a Lispy word. Individual things that you can, or the indivisible things like the numbers and characters, etc. And then next step you need is to collection of these things. So the lists and vectors and maps and sets are the workhorses of Clojure, because data is one of the biggest driving force behind Clojure code. But we kept on saying this is persistent. Maybe in the Clojure vibe, I actually looked up. So I need to define what persistent means.
You did some homework. A little bit. This is not really allowed, because you're going to beat me.
No. I mean, the only thing that
I'm a bit caught off guard by that, actually, Vijay. Looking things up. That's a bit. We shouldn't be doing that, really. Yeah.
I know. I promise to be stupid. But the one thing, remember, one of the running meme in the Clojure community, maybe not anymore, but every time Richie starts with a presentation and he'll explain the definition of it.
The
of a word
thing,
Exactly. So persistent, what does it mean? So persistent adjective means continuing to exist or occur over a prolonged period.
Oh, right. Okay.
So that's what I see from the definition.
But that sounds right to me. Yeah.
Yeah. Okay. So why are we calling these data structures persistent? Because they continue to exist. So if you create a list and then you append to a list or a conjoin to a list, then the previous so essentially we are creating a copy of the list because we are interested in immutability. But the idea behind is that you still have the older versions of the data lying around. Yeah. So when you pass the list around, you can still get access to it.
Yeah, I think it's a terrible word, by the way, in this. I mean, I know that it predates database persistence, so people want to use it, but I think it doesn't explain things very well. I think it would be better if it was something like generational. Because
that's true.
It feels more normal to talk about it like that, like version managed data structures or generational data structures, because persistent data structures just sounds like they're being kept on a disk somewhere. And I know they're not. I know it's durable. I get it, but but I think it confuses newcomers. This concept that it's persistent, it will stay forever. Because as you say, from the dictionary, from that dictionary definition, that's not what this is.
Yeah. But that's something that I think we need to live with. And
right, okay.
every time we need to say persistent, and then when I say persistence, it doesn't mean database.
I know. And it's like it's kind of like, to me, I'm not a fan of that really. I know that it's the right word for this context, but it's not very friendly, I think. But anyway, okay, like you say, it is what it is. But it really means generational. It means that if you add something to the collection or delete something from the collection, then what you get back is the previous version of that collection still exists. Yeah. So,
but the interesting thing with persistent data structures is that they don't necessarily I'm trying to compose my thoughts here. They don't necessarily mean that they are immutable in that sense, but they become immutable because that is the way you implement them. And also the thing is, it depends on what kind of persistent data structure you have, because you can have a completely persistent data structure. What that would entail is that you can because as we're saying, every time you modify, you're generating a new version. but you don't necessarily have access to all these versions of the data. So once you create a new version, then the older version is available for reading only, and you cannot quote unquote modify the older versions. But if you can access the older versions and modify it, then it is like a completely persistent or something like that. But if you cannot access the previous versions, I think it's called partial or okay, maybe I need to look up the proper words, but it's not fully persistent. It's not completely persistent because you can only access the new or the latest version. So that's the fundamental idea behind it. But yeah, I mean, the one of the nicest things with the persistent data structure, because they enable functional programming, because you're free to send references to a persistent data structure to across all the places. So that's why they are pivotal in making immutable functional programming thing. But one of the a little bit of history is that they're implemented as based on late Phil Bagwell's paper that called, I think, ideal hash trees or something, and they're called hash array map tree. So if you create some sort of a mental model of it, so persistent data structure is essentially like a tree, or at least they're, if I remember correctly or if I understand correctly, they're much more efficient to create a tree out of tree-based data structures. So once you have a kind of a binary tree or something, then it is easy to say, okay, there is a new version coming in. So you have one list, you have the second list, and you want to concatenate them. And then what happens is that the new list is created, and you have the first list, and the second list is essentially a pointer to the original list. So you don't need to copy the whole thing. So that's how they're implemented. But I think it was Phil Bagwell who made the original version, and then Richicke ported it to Java, or at least to Clojure.
Yeah.
So that is one of the biggest things in Clojure, I think. There was a talk by Richicke almost 6 years ago about how this thing scales up, and one of the advantages is that because the usually if you imagine a binary tree and you can scale it up to, depending on the number of nodes that you have at the leaf node, you can scale it up, and in Clojure they are basically 32 nodes at the leaf, so that gives you a large scalability. And what would that mean is that your performance is going to be effectively log n, I think, or log 32 base n.
I think it's log 32, but I think it becomes log 1 by the time you get to by the time you get a million records. It's nothing, is it, basically?
Exactly, and the number is, I think you need to have at least 1 billion records of them to actually go to the 2 power 32 limit when it is going to hit the performance thing. But usually you're not going to have 1 billion things in one array or in one list.
No,
I hope.
No. I think the point wasn't it, that it, like you said before, like doing these persistent data structures where you have all these generations. I think people felt, well, not just felt, people knew that it was very inefficient in terms of memory use. So it made it impractical, essentially, to have persistent data structures and fully persistent data structures like we have in Clojure. So people made all these countermeasures to only have, I'll just keep the previous version and then drop all the old ones.
Exactly.
So to have fully persistent collections where it is actually efficient as well. That's the secret sauce, isn't it, to this Phil Bagwell's paper?
Yeah.
It's not a secret sauce. Okay, he published it, but
Yeah, of course. But then every other language has, not every other language, I think Scala has persistent collections as well, thanks to Phil Bagwell.
Yes.
And Richicke took it over, and then we have this 32 node-based persistent data structures that form the foundation of Clojure data structures. And essentially they're immutable, and the immutability is the thing that is bringing in the Clojure's the other sales pitch. That is, Clojure is very concurrency friendly, and you can write very easy. You can write concurrent programs pretty easily because everything is immutable. So you're free to pass around the stuff around. That makes things much easier. So that's I think what my understanding is about immutability and persistence. And Yeah, I think that the other key nature of these collections is that they're lazy. So they probably don't get up in the morning quickly or something.
I was just going to say one other thing about these immutable data structures that maybe is a bit kind of subtle. It's not, maybe it's not subtle. Maybe I'm just a bit dumb, but I think it was a bit subtle to me anyway. Was that the fact is, if you hand over a version of, you run a algorithm of a version of the persistent data structure, you can still keep on adding to it outside of that run, and that's what you avoid in Clojure, is this concurrent modification exception. That you can modify that data structure while the algorithm is going over the previous version of the data structure. That's the magic to me. That is where you win, because you see, the version that you've got is completely stable. It's very much like Git in that sense, isn't it? You check out the code and you can do what you want with it. It's only when you put it back well, that's not quite like Git. Okay, forget it. But
you have this freedom to pass the data around, without worrying about it. Otherwise, if you're writing in Java, then you're locking all the time, or you're synchronizing all the crap, and you're worrying about, oh damn it, I'm modifying this one here. I need to wait for in the other thread, and it becomes much more complex. The more mutability comes into the picture, then it's becoming much more difficult to form the model of the program in your mind, and making sure that if the program is robust and resilient for multi-threaded execution.
Well, I mean,
so that is one thing.
Yeah, to be perfectly honest, I know that I think did Rich say this, that he read the book by Brian Gutz about concurrency and parallelism in Java, and then he said, okay, I need to write Clojure. Exactly. But yeah, it's it is like that, because I remember writing a program many years ago in Java that required synchronization. I was using some sorted tree map. It doesn't really matter. It was to do with PDF generations, but I'll give you the skinny on it. You had to do what I wanted to do was to basically throw the PDFs. Say I had 10 pages. I wanted to have each of those pages rendered on the server side individually, and then I wanted them sorted on the way back. But it was very difficult with Java to have lots of operations all going on at different levels all the time. In the end, I had to go very coarse-grained on the locks, just because I needed to do something, deliver something. It was very inefficient in the end. I know that, and there was a lot. I could get a lot. I would have been able to get a lot of better performance out of it, but I just didn't have time to do what you said. I didn't have time to analyze all of the possible cock-ups that could have went wrong. I did find a few cock-ups in testing, which is why I ended up just eventually making the locking coarser and coarser grained, to the point where I just locked everything, which was honestly, I'm sorry everyone about that. It was pretty dumb, but I had a deadline to meet, and it worked, but it was very inefficient. Whereas with this kind of stuff, you're on safe ground. You're putting that stuff in there, you throw it out, it all comes back. It's all lock-free. It's very stable, and it gives you those kind of opportunities for optimizing your performance without worrying about those locks. Because I think that's
true. Because
it's a lot of headache to think about all those kind of things and to test them, and as you say, to really guarantee it and formally prove it. It's almost impossible, and certainly no normal working programmer would do that.
I wrote some network programming in my previous incarnation, or I don't know, previous life.
Do you believe in that as well, by the way, the vegetarianism?
Well, I'm persistent, so there was a version before me. Remember how Richiki was introducing the concept of, the ID and the value?
Oh, yeah.
So, there is a person, and then you have person has an age, but has some age, and it's changing all the time. But at that time, it is a fact. So that is the core of Datomic. Well, let's not get there.
Well, but you're right, though. No, honestly, the whole point about this is that it translates very well into the Datomic world. We're not going to go there now, obviously, but in general, that's what Datomic is, isn't it? It's basically this whole thing. But on a disk somewhere, or on a cloud storage somewhere. So you have truly persistent data structures. Okay, they're durable, but in the words of Atomic, but yeah, they add durability to this kind of whole collection thing. Which I think makes it super appealing as well, because then you can the notions scale out, don't they? You scale in one kind of in one thread or one virtual machine, and with Datomic it then suddenly scales out to across very many virtual machines.
Yeah, and also you get the immutability at the data level in the database as well. You can say, okay, because that's how the world operates, right? At some point, those are facts. I mean, they don't just change. You just add more information. That makes the older information obsolete. I mean, you don't just replace, you don't just change it in place, but there is a new version of it being available. But anyway, so
we'll do a talk about that another time, I think. Yeah. But it's great stuff. So I mean, but it's good to know that. I think just to round it off is that a lot of this stuff comes from a lot of the further work comes from these foundational things.
Yeah. And then we have this, of course, these collections are lazy. So by lazy, when we say it's not realizing the entire collection, because of course you can read the entire Wikipedia into memory and then put it into a collection line by line. Then but if you want to process it lazily, then you need the lazy thing. So the idea behind laziness is that you only realize, or reify is proper word, I think, to make it come into existence. That's what reify means, I guess. Anyway, so if you have
that's not, you should have looked it up in the dictionary.
I promised that this show is going to be at my stupidity is going to be at a constant level, so I don't want to cross it. But anyway, what I was trying to express is that if you have a collection and you don't necessarily need to realize all the values, you don't need to compute them. So you compute them on the as and when needed, and that makes it the whole thing lazy. So then. Also, the advantage there is that now you can have infinite collections. You can have all the numbers. Okay, give me a range from 1 to infinity, and then because you actually don't need all those things, but you can ask it for, okay, give me first 10, give me first 20, whatever. So that makes things lazy.
It's an interesting comparison, though, isn't it? Because the question then is like, what's a collection versus a stream of data values?
Yeah. But I think we are now crossing the boundary and then going into the transducer view of the world, I suppose. If you say, it's just a collection and it is supposed to just give you the next one when you ask for it, then it could be a channel, it could be data coming over the network, it could be anything. So it's not a collection per se.
But I think what you're hinting at is that, or what you're talking about is like this whole lazy evaluation thing, is that it can be a collection that you're reading from, but that collection can be generated through some function.
Exactly.
And it's the lazy, what should we say? Like
lazy evaluation.
Lazy evaluation, because what you're really doing is if you make a collection, if I make a collection of 100 records, then that's not lazy, is it? I mean, it really has got 100 records in it.
Yeah.
It's when you want to put a function over that particular finite or infinite collection, isn't it? That's the lazy part.
Yeah, that's true. But one of the trickiest parts with the lazy things, I remember when somebody asked Simon Peyton-Jones, one of the authors of Haskell. So he said, how would you change if you have to redesign Haskell now? He said, okay, I would remove the laziness.
Really?
Because because that is because the laziness gives you kind of weird surprises, because Haskell is completely lazy at every point, even the function evaluation and everything. And that makes debugging painful, because you have no idea when things are going to be called. So if you have a network of functions and you have no control on when something, what is the execution model of the program? So he said, okay, I would avoid laziness and I'd go for strict by default, then introduce the laziness whenever you want. So that's an interesting viewpoint of the laziness, though.
I thought because I think you've read SICP as well, or looked at, because I remember in the SICP thing, they were talking about laziness, weren't they? And they were saying the problem with laziness is that you don't know if something's going to come.
Yeah.
Actually, when you're trying to unify two streams, for example, you don't know what the order of the arrival is, and we know from the event stream processing world that stragglers are a kind of a problem. Anyway, I was going to we're getting a bit advanced there, I think. Or out in the woods, let's say. One of the examples we were talking about before, though, was this like comparing like a lazy evaluation versus a SQL on a database.
Database, like cursors.
Like cursors, because oftentimes people would compare it like that. But my view of it is that cursors are kind of like half lazy, because you as a program, you can say, okay, give me the next value, and it sometimes it does a prefetch and it brings back, a megabyte or 32K or whatever over the wire, and it seems lazy. It seems like it's evaluating that lazily, but actually it really isn't, because if you go on the database server side, it has evaluated it, and that's a huge difference to me between what these kind of things are in Clojure, model in Clojure, and the database cursor model.
Yeah.
Because if I have two infinite sequences in a database, that doesn't exist. I can't generate that. Well, the classic one is the Cartesian product, isn't it? If I do a query, select star from emp and personnel, and I just do a Cartesian product across the two tables, then if those two tables happen to be a decent size, the database is going to blow up.
Yeah, of course. Then it is going to put everything into the memory, and then trying to, but from the reading point of view or the network, you will still think there is a cursor being available. So I'm going to ask for the next one.
Well, the thing is, it will never. Actually, the funny thing about that is it will never come back, because it has to realize the Cartesian product first. So that's the opposite of lazy, isn't it? Whereas with lazy, you're doing it. You're computing the next value on demand. Whereas with the Cartesian product, you generate it all, and then you give back the first record and you consume it lazily. And I think that's the difference. It's like the difference between like lazy consumption versus lazy generation.
Yeah, that's true. But I think I remember somewhere, maybe it's MongoDB or something, then you can have server-side cursors. But let's not talk about MongoDB, because it's not fun. I mean, somebody was saying that, hey, it's a Snapchat for your data. So,
well, it's not written in Clojure, so it doesn't exist as far as I'm concerned. No, we're using it at work. I do know about it. Yeah, it's an
interesting database.
That's for a Mongo podcast. That is,
Yeah, but one of the tricky parts with having laziness is this whole concept of holding on to the head, right?
Yeah.
Because you're trying to realize something, and then if you
but the head is the front, isn't it?
Yeah, exactly. The front of the data structure. Well, front. Yeah, top.
First.
I don't know. First. Yeah, exactly. So when you say when you see the implementation of this one, then what it would mean is that you have a list, and we were talking about the sequence abstraction on top of it. So you have the first element, and then rest of it is again another sequence. And then you ask for the next element, then you have the first element, second element, and then rest of it is a sequence. Now, especially if you are iterating, which is probably a bad word in functional programming, if you are going over a collection, then if you hold on to the head, what would that mean is that you are having a reference to the data while you are going through the collection, then it will accumulate into the memory, and you will end up, getting out of memory error or something. So that is a something that you need to watch out for. How do you prevent not making too much, not accumulating too much into the memory.
Yeah.
So that is an interesting thing to watch out. But how are we
going to avoid that though?
Well, I think one of the ways, there are multiple ways you can identify it. I remember there was a Stack Overflow post by Michal Marz explaining that you need to monitor it. You can monitor it by using what's it again? I think it's called the persist. Sorry, no, it's not persistent queue, but the JVM has a couple of APIs that you can look out for, and you can ask for, has it realized? Is it something? Then you can write tests for it, but it is pretty tricky. But whenever you're writing code, you need to make sure that you when you assign a variable, not a variable, but when you assign a var, you need to know that you're going through the list and be careful in terms of how you're consuming from it. So that is, but
because I think you have to be.
There are lots of examples on the net.
And I think
it's very difficult to read out code in the, in the podcast.
I think the difficult thing isn't it, is when you're doing some of these operations, you may sneak. It can sneak up on you, can't it? I think that's the part of the problem. Is you have to be careful that you don't introduce some function or some operation that accidentally makes you hold on to it. But okay, like you say, look it up on Stack Overflow, people. You know, we're punting on that one.
Exactly.
It's an issue. Yeah, be aware of it and look it up. Yeah, okay. So we're not being very helpful there. we can't solve all the problems, you know.
So don't hold on to the head.
Yeah, don't hold on to the
That's
head.
what
Don't
we want
have
to
just be say
exactly.
that. Yeah, but actually, talking about that kind of thing is that definitely there are some occasions, aren't there, where you do, you know, like Simon Peyton-Jones. There, you want to be eager sometimes. You know, if you're going to do some side effecting things, or you're going through some list where you want to print some stuff out. The classic example is you get this list, and you think you're going over like a database. You're going over some set of operations on this thing, and then you run the function and nothing happens. It's like, what happened here? You know, but actually it's all because it's being evaluated lazily. So it can be a surprise when you first come to the language. Then you need to know. Okay, actually. This is the benefit of being lazy, but I don't want it in this occasion. So what do? Then you have to use this Doall or doseq thing where you want to force the generation of the list of the sequence operation. So there's just a little comment there that, you know, typically you don't want to do that, but if you do want to do that, then you have the options to be able to do it as well. But you were telling me something beforehand about some performance trick that you've been using recently with these persistent data structures.
Exactly. So there is an interesting, as you're pointing out, I mean, you're using lazy, and then sometimes you want to be eager. So you have functions for it, like doall, doseq, you know, to realize the whole thing. So you have an option of going to the other side. And in the persistent data structure world, as we were trying to explain, that there is a copy made every time you want to create a new version of the data. So every time you're appending, every time you're concatenating or conjoining, you're creating a new version of it. So, but there are situations where you don't want to create a new copy because of the performance reasons. So that's where you use a transient data structure or the transient function. So what you can do is create a transient version of the data structure that you want to use. And you have operations that take advantage of the mutability. And then once you are done, you can convert it back into a persistent data structure and then give it back to the world. So one example, I think it's in the probably Closure Applied book by Alex Miller as well, is that when you want to load large amount of data, then essentially creating, if you are doing this conj or concat or assoc, whatever, then it is going to be a big performance hit because you are loading bulk data and you don't want to keep creating copies. Then you want to take advantage of the performance. So it's pretty nice use case for you know, jumping. That is the choice that you have. So you can make it program faster. I think at least 4 or 6 times by switching to transient locally within that function to load the data, and then once you're done, you just give a persistent data structure back. So that's an interesting performance trick.
So that's cases where you basically want to front load some. Obviously, the performance is predictable anyway, but what you're talking about here is like you want to front load some data, like from a log or something like that, pull it all into memory, and you want to do some small operations on it to maybe parse it or to filter some stuff on it. but you don't want to pay the
Exactly.
cost of a generation every time you do an source or a conj on it. It makes a lot of sense, actually. But obviously nervous of saying that it's that the performance is bad. It's just that you're tuning for it in that particular use case. Yeah.
Exactly. Yeah. But that's the choice that you're making when you're using Clojure. The thing is, it gives you enough. Defaults are pretty awesome, but then at the same time, you're whenever you have to reach out to the other tools, there are workarounds available.
Yeah.
And another example is that the type hints, right? I mean, type hints help you to prevent reflection, and then you don't need to use them, but especially when you need them, they're there. So you can make them use primitives, you can make them use the real types, so it doesn't need to do reflection. So if you're going towards, okay, I want to make it really performant, then you have access to these kind of tricks.
Yeah, you can
that's the idea.
Take away some of the defaults to get some big benefit. But like you said, I think what you're saying is a nice trick, though, where you keep it very local to one function, and it just does its work, and it knows that it's safe to do it. Because obviously you don't want to be giving back transient collections, because that would be a horror show. Because you lose all of this wonders of
no. It should always be local and controlled.
Yeah.
So that's the idea.
Cool.
Yeah.
Okay.
Yeah.
Right. Well, we probably should move on finally just to some general things like from the community, because I think we've talked a lot about the kind of core stuff, haven't we?
Yeah.
And I just a quick shout out. There's a lot of publicity around it because he made the keynote at Clojure West, but Nathan Marz did a great job here in terms of this SPECTER library that we were talking earlier on about. Sometimes you get back different values from the conj or the concat or the source or whatever, and he made the SPECTER thing, which gives you a lot more control over that. You have a much more ability to specify consistently and easily what the output data structure is going to look like. And I think that's it's going to be very nice where you've got big data problems, I think. And I like the fact that he's taking it to the next level as well and making it open so that you can extend his types also. You can extend the library. So to apply all of the kind of navigational and editing stuff that he's put out there. But I think also we had a look at some other community contributed collections as well, didn't we?
Yeah, of course. I mean, there was one by obviously Michal Marzek has been a prolific contributor to Clojure and Clojure script.
Big shout out to Michal.
Michal, he is pretty awesome, and he was very kind to come to Dutch Clojure Days, and he gave a talk at one of the previous Dutch Clojure Days as well. And so he's one of the guys who's working on the data structures a lot, and he made his own version of the AVL trees, which is basically a tree data structure, but much more what they call like a balanced tree. So the height is optimized, so you have access to the nodes pretty with less number of hops, lesser number of average hops. It's basically weight balance things. I wrote down the names of AVL Russian scientists though. So AVL is Georgy Adelson Velsky AV, and L is Evgeny Landis. I apologize to all the Russian listeners. that's what I could, I tried my best. I really hate to pronounce names wrong, but anyway, so that's the AVL trees, and he also did a concurrent lock-free data structures, which are based on which is an idea that is implemented in Scala before, called C-trees. C-trees, I think they're still pronounced as trees, but written as TRIES. I think
it's very confusing.
Yeah. I think it's a tree, but with IE.
Yeah. The AVL thing, by the way, I need to use that one of these days for the stream processing stuff, because I think he has these time rank queries which I haven't used yet, but I've been very I did a blog post about time processing with core async, but somebody suggested to me that if you put them into these AVL data structures, you can get this time ranking for it wasn't really relevant for my use case, but I think it looks very interesting for a lot of this event stream processing, where you have these time windowed series and stuff like that. So great job by Mikhail Marchik there. We're definitely great guy. Often does presentations at the conferences as well. So very good. And Chris Hauser, of course, in the early days, he's did a lot of stuff, and he still has this data.zip for filtering trees. He's also got a lot of XML support in there. That's really good. And the other thing I noticed at the last Clojure West was this guy Peter Schuck. He did the lean hash maps. So it's actually taking this whole HAMT thing we talked about earlier on. This this hash array map tree again. Tree with an R
with an IE.
Yes. And there's been some researchers, a paper by Stanford and Vinju last year, talking about how to do these lean hash maps, and they've got some claims, at least in terms of iteration and equality checking, which are quite impressive. And I know that he's talked to David Nolan about performance checking these things, because he wrote them in ClojureScript, by the way. And they're looking at thinking and seeing whether these improvements in performance for certain operations actually hold for all the operations. So obviously you don't want you don't want to have a swings and roundabouts thing. You want to try and win everywhere, or at least keep everything kind of stable, but have some improvements in some areas. That's what we're looking for, isn't it? But the thing about the thing he mentioned, which was quite interesting, was that it was a lot less code. So he thought that it was, apart from anything else, was a cleaner implementation. But it's a very good presentation, I think. Very well worth the watch. So shout out to Peter on that one as well.
Yeah, I mean, I didn't see that, but I'll probably watch it now because you gave a quick summary or a TLDR for that one. And of course, there is also another. I think it's part of Clojure core as well. The priority maps or the data priority map. So you can have a sorted map, but you can associate some sort of a priority into it. So the entries are sorted based on the priority. So there are lots of nice libraries available out there. I think we'll put links on our blog, so people can look it up.
Right.
I think the priority maps are by Mark Engelberg.
Yeah, it's a Clojure family, that, isn't it? Him and his son seem to do incredible work around Clojure. The Engelberg troop. Right. Okay. So I don't know. I think we've actually just passed the hour mark, so I think we should probably stop now.
I suppose so, because otherwise the people who are using our podcast as the workout counter,
they're in the shower and
it might be overworking.
It's going to ruin their MP3 player. Yeah. We don't want to be blamed for that. Yeah.
Yeah.
All right. So, what? Anything? Final comments, Vijay?
I'm still wondering about what we're going to talk for the next time. I know we talked about the asynchronous models and stuff, so probably we'll pick up on stream programming and concurrency and asynchronicity a bit. But we'll explain it in the next podcast, I think.
Yeah.
But we'll come up with that.
All right.
But it's obviously the podcast is available on the regular outlets. It's available soon. If you are listening to this, I think it should be available now. It's kind of a
that's a
self-fulfilling thing. So we'll post the notes to Defen.audio, and obviously SoundCloud will be there as well. And we'd really appreciate if you give us feedback on Twitter, or via Reddit or Google Groups as well. I'll post the links, and we are also available on Clojure Slack, and I'm also occasionally idling on IRC if people who are still using it or not. I don't know.
I'm never on there actually, but
okay.
But you're more social than I am anyway.
I maybe online. I think in person probably I'm not that social.
Oh, come on. Anyway, okay, so that's good. Thank you very much. I think we just one last credit actually. We have to do these things, and it's an awesome bit of work by Pizzeri. He did the intro, outro music for us, and I really like that actually. I think it's a very nice tune for our podcast. I hope that people enjoy that music when they get the podcast downloaded and get sat in their chairs or their cars or whatever. And so thanks to Pizzeri for that. Melon Hamburger is the title of that track. So go and check him out on SoundCloud because he's doing a great job there. Yeah. So that's it. So Vijay, thanks very much.
Thanks, Ray. And it's been fun again. And we're going to come up with the episode 5 pretty soon.
So see you next time then, mate.
Yeah, see ya.
Bye.
Bye.